All right. I don't think it's working. It is working? Okay, all right. All right, if it's working, if you say it's working, then it's working. All right, so what we're going to talk about this morning is network virtualization. Anybody heard of this? This is probably new to a lot of you. Okay, all right. So we're going to be talking about this. I called this, you see my subtitle here, I call it a no-nonsense look, because what I tried to do here is be very, very practical about what network virtualization is, as well as what it isn't. Because there's a lot of buzz, hype, if you will, around this and an associated term, software-defined networking, SDN. Who's heard of that? Right, okay. So a lot of hype, a lot of buzz around what this is, and I wanted to be very practical for you guys about what VMware feels network virtualization is and where VMware's trying to drive network virtualization. All right. Again, information, thank you for the wonderful introduction. My name is Scott Lowe, and there's some information about me. And I think they mentioned this during the introduction, but in case you thought you recognized my name but weren't sure quite where you saw it, it was probably on the front of one of those. And did you guys mention that you're giving away a couple? You did? Yes? No? No, you did? Okay. So can I tell them?
Yeah.
Oh, okay, all right. So I was actually able to secure some copies for the raffle, the giveaway, later today. So we have 2 copies of this book, and then 2 copies of this one, which is brand new. It just came out, like, I don't know, last week, right? So, and I'll be happy to sign them if you want. You don't, I don't have to, but if you want to. So be sure to stick around for the final raffle, because we'll be giving those away at the end of the day. All right, so let's look at what we're going to talk about today. What I wanted to start out with is, this is kind of an outline of what we're going to talk about. I wanted to start out with looking at what network virtualization is not. Right? There's a lot of hype, a lot of buzz about network virtualization and software-defined networking. So I want to start and say this is what it is not. And then from there we can look at what it actually is, look at a definition. All of you in here probably are very familiar with the idea of virtualization or server virtualization, or what I termed on here compute virtualization. So I want to draw some similarities between what you know about compute virtualization and align those up with what we're doing with network virtualization as well. And then talk about some benefits, and then if time allows, I'll have some Q&A, but of course you're welcome to ask questions during the presentation as well, although you're allowed to speak up since we don't have microphones for everyone in here. But just raise your hand if you have a question. All right, so in creating the presentation, I was thinking about how I wanted to present network virtualization to you guys, and I came across this quote. It's attributed to Albert Einstein, and I thought that it was pretty applicable, and it says, if you can't explain it simply, you don't understand it well enough. So hopefully, I understand it well enough that I can explain it simply to all of you. That is my goal today, is to be able to explain what network virtualization is, and do it simply enough that you'll be able to understand. So what is network virtualization? Network virtualization is not these things, all right? And I think it's important to kind of set the stage when we look at this and talk about what network virtualization is and what it is not, all right? One of the things that it is not a specific technology, right? So we talk about network virtualization. Network virtualization encompasses a number of different technologies, okay? Not just one specific technology in particular. It's not a protocol, okay? So when we start talking about things like network virtualization and software-defined networking, the first thing that comes to people's minds usually, especially, who in here is a networking professional? I mean, like, that's the primary thing you do. Anybody? Okay. So, networking folks in particular, we love to talk about protocols, right? You know, good or bad is kind of how it is. When we talk about networking, we love to talk about protocols. But network virtualization is not a protocol, right? Now, it might use a protocol. It generally will use a protocol, but when we talk about network virtualization, we're not talking about network virtualization being a protocol like STT or VXLAN or NVGRE, right? These are components of the overall network virtualization solution, but in and of themselves, a protocol like VXLAN is not network virtualization. It's a component. Another related protocol. Network virtualization is not OpenFlow. Who in here has heard of OpenFlow? Okay? So OpenFlow, for those of you that aren't familiar, it was a protocol specification developed to allow you to modify how a network switch forwards traffic, right? And the idea being that if you could write some code using the OpenFlow protocol, then you could then control or modify how a network switch would forward packets through the network, and you could do so in a very granular fashion if you so desired. And it was really OpenFlow that kind of gave birth to the next acronym we see on our list, which is SDN, or Software Defined Networking, right? And so by association, many people feel that when you say network virtualization, you're talking about OpenFlow, and when you talk about OpenFlow, you're talking about SDN, and when you talk about SDN, you're talking about network virtualization, and really these three things are very, very different, right? So network virtualization is not OpenFlow. It might use OpenFlow, but network virtualization is not OpenFlow, and by association, OpenFlow alone is not necessarily network virtualization either, all right? And the same thing here as last point, network virtualization is not necessarily software-defined networking, all right? Especially where software-defined networking, SDN, is taken to mean I'm using OpenFlow, right? Software-defined networking can mean many things, but again, in the industry, many people seem to associate SDN with the mere presence of OpenFlow in the network, and there's really more to it than that. Does that make sense to everyone? Okay. So as I've said a couple times, network virtualization really could leverage, and probably will leverage, any or all of these technologies, but it's important to understand that network virtualization is more than just one technology, it's more than just one component, it's more than just a protocol. It's a combination of all these things. So if this is what network virtualization is not, then we can now take and look at what network virtualization actually is. Okay? And this is as non-marketing as I could get it. Okay? So I tried to remain as technical but also simple. It's an abstraction layer. And the purpose of the network virtualization abstraction layer is to decouple or separate the ability to create and define and manage logical or virtual networks from the underlying physical networks. Okay? Now that's a great text definition, but who would like to see a picture? Great, I thought you would. So here's a picture. Pictures are helpful. I think they are anyway. So let's look at this a little bit. And I'm probably driving the camera people crazy. I apologize. I can't help it. I move around when I talk. So we talked about network virtualization being this abstraction layer. So much in the same way that we have an abstraction layer in the hypervisor. Right? So we have vSphere and ESXi, and those are the abstraction layers for our compute workloads. Right? We all understand that that abstraction layer provides a separation from the virtual machines which are running on the physical hardware and the physical hardware on which they're running. All kinds of benefits that come from compute virtualization, which is why VMware is so successful and why all of you are associated with VMware, right? Because it gives you lots of benefits in your data center. The same sort of thing applies to network virtualization. So when you look at this, we've created an abstraction layer that allows us to separate the idea of a virtual network, right, from the physical networks underneath it. So we can have a physical network infrastructure here comprised of switches that are forwarding IP traffic, and all they have to do is just forward the traffic. And all of the configuration, all of the policy, all of the management of the logical networks that comprise the applications that you're running, the workloads that you're running, maybe you're supporting multiple business units or multiple tenants, whatever the case may be, all of that is pulled away up into the network virtualization layer. All right, so much like compute virtualization, and this is where we're actually going next, is it provides a number of benefits. So let's make some comparisons, okay? I used to say when I was explaining to people about compute virtualization, about server virtualization, that it kind of gave us three key benefits. And I know that I have more than 3 bullets here, so that's okay, I understand. We got hardware independence, right? I can take a virtual machine created on an IBM server and I can migrate that to an HP server or migrate it to a Dell server or migrate it to a Cisco server, and it doesn't really matter what that underlying hardware is. There's just one thing in common that I had to have. What was that? Aside from VMware software on there. What was the common thing I had to have across all those servers? Same hypervisor, yes, of course, right. But we also had to have an x86 processor underneath it, right? Okay. And so that was kind of the common denominator. We had to have this x86 compatible processor underneath all this, and then of course the VMware software on top of it. By the same nature, okay, we in network virtualization, the only thing we require underneath network virtualization is IP transport. So we're just moving IP traffic, okay? We don't require any special hardware support. We don't need any specific kind of hardware. It works on any physical hardware as long as it will forward IP traffic, which pretty much everything out there today forwards IP and Ethernet traffic. Right? That's kind of the standard. Just like x86 became the standard in the data center for compute, IP and Ethernet are the standard for networking in the data center, by and large. Anybody here have a data center that's not running IP and Ethernet? Okay. I thought for a second I saw a hand raised. No, nobody raised their hands here, okay, in case you didn't see that. That means it's pretty much, it's a standard. Everybody's got IP and Ethernet running in their data center. And that's all that's required for a network virtualization solution is IP and Ethernet. That's it. No special hardware, no specific switches, no underlying support, anything of that nature, just IP and Ethernet, right? And as I mentioned, what it does is it separates the logical networking from the physical networking, right? So when I talk about this logical or virtual network and the physical network, I want to draw a comparison for you. Right now, your limit on virtual networking is creating a virtual switch, right? That's it. I can create a virtual switch. I can't create these topologies of switches. I can't create multiple subnets. I can't create routers and connections. I can put in some firewalling segments with vShield app or Edge if I wanted to do that, if I'm using vCloud Director. But it's pretty limited, right? When we look at network virtualization, what we're going to be trying to accomplish is allowing you to build the kind of complex network topologies that any application could require. Maybe it's a multi-tier application with a database tier and an application tier and a web tier, and you need these to be separated on different networks with firewalling in between them, right? This would be hard to build using today's network technologies, but what we're shooting for here with network virtualization is the ability to create that sort of complex topology, right, over any underlying IP Ethernet transport. So decoupling all of that network policy, decoupling all of that network configuration, so creating the logical networks that you need for applications, applying quality of service, traffic shaping, security guidelines, all of that stuff, all separated out from the physical network into the logical network. So that all the physical network has to do is forward traffic. It doesn't require any changes to your applications or your workloads. Well, one of the great things about compute virtualization is that you could do P2Vs. How many people did a P2V in the past? Just out of curiosity, when was the last time you did a P2V? In the last year? Yeah, okay, all right, got a few people, all right. And so the great thing there is you can take an existing workload running on a piece of physical hardware, right? I could pick that workload up, I could drop it into a virtual machine, and by and large, it worked without any changes at all, right? You guys saw that when you did your conversions, right? That was the beautiful thing. That's what made compute virtualization so incredibly successful, is that we could take advantage of all the benefits that it offered, but we didn't have to go back and rebuild all our applications and recreate everything. We could take what we already had and we could move it into the virtual world, and it would just work, right? And that's the goal behind network virtualization as well, is to be able to take your workloads right now that aren't running in these logical networks and be able to migrate them into logical networks that are completely decoupled from the physical network and not require any changes at all to your application in order to be able to take advantage of that, right? Which means we're not saying you have to go back and rewrite applications or anything of that nature. You can take your existing applications and migrate them into a virtual networking solution or a network virtualization solution as well. Now, I've mentioned several times that I don't require any underlying hardware support, right? But that doesn't mean that I can't take advantage of some support in the hardware if it's present. How many people remember virtualization before Intel and AMD hardware support, right? And VMware used something called, yeah, a few of us remember, VMware used something called binary translation, which allowed virtualization to occur even when the underlying processor had no idea what was going on. The processors had no support whatsoever for virtualization, but we still supported virtualization. And then Intel and AMD came along and said, hey, we think there are some ways we can make virtualization even more efficient. So we're going to introduce some hardware offloads to do that. And that's where the Intel VTX and AMD extensions came in, and then VMware adopted the use of those to enhance the existing virtualization functionality. I expect we're going to see the same sort of thing on the network virtualization side, right? Right now there isn't any hardware support, and we don't need any hardware support in network virtualization, okay? But over time, I expect that the hardware vendors are going to start building hardware offloads into their hardware, okay? And whether those hardware offloads are for things like protocols, right? Whether it means, okay, Intel's going to build the ability to offload VXLAN into the NIC, right? Then there's no harm in that. We'll be able to take advantage of it, but we don't require it. Does that make sense? Yeah. Mike, get a question?
Yeah, I mean, the CPU offload and regard by and VASA, the storage offload is being some kind of thing. Is the overhead associated with network virtualization so great that if the hardware vendors did that, it would suddenly be blisteringly quicker than it was, or is there improvement in performance and then how quickly is that offload?
Yeah, that's a good question. So the question was, how much kind of overhead, if you will, is there with network virtualization, and will this future hardware offload, should it arrive, and I don't know if it will or it won't, how much will it actually improve that? The overhead today is predominantly in the area of the protocol, where we wrap network traffic inside another protocol to provide the isolation we need, right? So one of the benefits we talked about here is the ability to create these logical networks which are completely decoupled from the physical networks. And that means that we also have to decouple things like addressing, IP addressing, and even MAC addressing from the underlying physical network. We do that with an encapsulation protocol. And there are a number of encapsulation protocols out there on the market, and the predominant one, or two really, are from the VMware space, VXLAN and STT. So the overhead predominantly comes in the protocol space, where we have to encapsulate that, and the overhead, it really isn't that great. Okay. Now, one of the protocols, STT, was designed specifically to take advantage of a hardware offload that exists today, without requiring vendors to do that. But we anticipate that over time, the rise of protocols like NVGRI and VXLAN, they're just going to build those offloads right into the hardware, and it'll be essentially non-existent at that point. Does that answer your question?
Is there a particular type of network traffic which is particularly more painful when you're doing network virtualization compared to another type of network traffic?
All right, so the question was, are there some types of network traffic that are affected greater by network virtualization versus others? Not really. Multicast is a little more challenging to address, but not really a problem. So if you have strong multicast, heavy network applications, they're a little more challenging to address, but not impossible.